Hey friends, welcome back to Math Defined. Today we're going to compare two sample groups using real soccer data and answer a big question. Who's actually performing better, and how can math help us figure that out? Because this isn't just about soccer, it's about learning how to use data to make smart decisions in real life. So imagine this. A coach randomly selected 15 beginner players and 15 advanced players from a soccer training program. We're going to use these random samples to answer one big question. Do the advanced players actually perform better? And does the data back that up? Well, let's find out. Before we compare anything, let's take a minute to make sure we're comfortable reading this kind of graph. Here's a quick refresher on a Box-and-Whisker plot. The whiskers show the smallest and largest values. The box shows the middle 50% of the data where most of the values fall. The line inside the box is the median, which tells us a typical value for the group. And the interquartile range, or IQR, tells us how spread out that middle 50% is. And that's all we need to confidently start comparing these two sample groups. The very first thing I always look at when comparing two groups is the shape of the data. When I look at these plots, I notice they're skewed. The boxes aren't centered, and one whisker stretches farther than the other. That uneven stretch tells me the data isn't balanced. And when data is skewed, we don't use the mean. We use the median to describe the center and the IQR to describe the variation. Now let's look at those medians. In the beginner sample, the median kick distance is 60 feet. In the advanced sample, the median is 90 feet. So a typical advanced player kicks about 30 feet farther than a typical beginner. Now let's look at how consistent each group is by using the IQR. We find the IQR by subtracting quartile 1 or Q1 from Q3. For the beginners, Q3 is 80 and Q1 is 30. So 80 minus 30 gives us an IQR of 50 feet. For the advanced players, Q3 is 100 and Q1 is 80. So their IQR is 20 feet. Since 50 is greater than 20, the beginner's kick distances are more spread out. That tells us beginner kicks vary more, while the advanced players' kicks are more tightly grouped, which means they're more consistent. Now let's take this one step further. What if we're looking for a kick distance of 95 feet? Which sample is more likely to include that value? If you look at the plots, 95 falls right inside the middle of the advanced sample. So based on these graphs, the advanced group is more likely to have a kick that distance. Now here's another question to think about. Which sample is more likely to have a kick that differs from its median by at least 30 feet? Remember, the beginner sample had a much larger IQR. That tells us their data is more spread out, which means bigger differences from the median happen more often there. So in this case, the beginners are more likely. Putting this together, based on these samples, the advanced players appear to kick farther and be more consistent. But let's not stop there. Let's see what happens in a second soccer drill. We saw what the kick distance data showed us. But let me ask you, is that the whole story? What if, instead of measuring how far they kick, we look at something different, like how many successful passes they complete in a drill? Take a look at these dot plots. What do you notice first? The dots are fairly balanced on both sides of the center. Nothing is stretched way out to one side. That tells me this data is approximately symmetric. And when data is symmetric, we have to adjust our strategy. Instead of using the median and the IQR, we use the mean to describe the center, and the MAD, the mean absolute deviation, to describe the variation or how spread out the data is. Let's start by finding the mean. To do that, we take the total number of passes and divide by the number of players, starting with the beginners. Instead of adding every single dot one at a time, we group the dots that sit at the same number. For example, I see 3 players with 0 passes, so that's 3 times 0. Then I see 1 player with 10 passes, so that's 1 times 10, or just 10. We keep doing that, multiply the number of players by the number of passes at each value until we've accounted for all of the dots. When we multiply and add everything together, we get a total of 420 passes. Now we divide by the number of players. There are 15 beginners, so 420 divided by 15 is 28. So the beginner's mean is 28 passes. Now let's do the same thing for the advanced players. We group their dots, multiply and add, and their total comes out to 810 passes. Divide 810 by 15 and we get 54 passes. So the advanced mean is 54 passes. Now let's find their MADs, the mean absolute deviation. Think of the MAD as the answer to this question. On average, how far are players from their team's average? Are most players close to the average, or are they kind of spread out? Before we can find the MAD, we have to go back to something we've already found, the mean. The MAD measures distance from the mean. So that mean we calculated, that's our starting point. Let's begin with the beginners. Their mean is 28 passes. I see that 3 beginners had 0 passes. To find how far 0 is from the mean, we subtract 28 minus 0 to get 28. So those 3 players are each 28 passes away from the mean. Next, I see 1 player with 10 passes. 28 minus 10 is 18. So that player is 18 away from the mean. We continue that same idea for every value. Find the distance from 28, multiply by how many players are at that value, and then add all those distances together. When we do that, the total distance comes out to 236. To finish finding the MAD, we divide 236 by the number of players. 236 divided by 15 is about 16. So the beginner's MAD is about 16 passes. That means a typical beginner's number of successful passes is usually about 16 away from the average of 28. And if you'd like a full step-by-step walkthrough of this process, you can check out my separate video on how to find the MAD. Now we repeat the exact same steps for the advanced sample, just using their mean of 54 instead. When we calculate all of their distances and add them together, we get 244. Divide 244 by 15, and we also get about 16 passes. So both groups typically vary about 16 passes from their averages. Now here's the part where we bring everything together. The difference between the 2 sample means is 26 passes. And we know the typical spread, the MAD, is 16 passes. So what does that tell us? Since 26 is greater than 16, the gap between the 2 groups is larger than the normal variation we usually see within one group. But we can make that even more clear. If we divide 26 by 16, we get about 1.6. That means the 2 averages are about 1.5 times the typical spreads apart. In other words, the difference between the groups is bigger than the normal everyday differences we see within a team. So based on these random samples, the advanced players are clearly performing better in this drill, and we use math to prove it. Here's the best part. We didn't argue about who was better. We didn't guess. We didn't rely on opinions. We let the data do the talking. And when you can use math to prove something clearly, that's powerful. And that's how we let math do the talking. If you're ready to go deeper, you can find this lesson along with self-paced courses at mathdefined.com. Be sure to like and subscribe. It's free, and your support helps this channel grow. I'll see you in the next lesson, and until then, keep math awesome.